So welcome everyone to today's session. As I said earlier, we really appreciate you showing up. We are really excited to see all of you guys supporting us up to now. It is expected when things get tough, some people allow the challenge to be tougher than them. But it's very clear that you guys have tougher than the challenge that you have at hand. So we are really excited to see you guys, and we are hoping that we'll continue together. So I'll go straight to today's agenda. So we are kicking off the development. So the basic idea is for us to just do a recap of what you're doing again, and then we can also look at a few things that that we need to do as a team. My objective today is to help you, to remind some of you what you're doing, to do a brief recap of what you've done for those of us who have not been with us through the whole journey, and remind you some of the things that we've learned and why they are necessary. And then eventually we will go back to, we will finish with what we need to do for us to create an SMSC. So I will be highlighting a few things that we've done, myself and some of the telecoms engineers. So we have a very high level architecture of what we have to create. But we need you guys now to help us do the low level architecture and actually implement what we need to do. So I will go straight to the challenge. So we are building an SMSC. And for those of you who don't know what an SMSC is, it is the network element within the telecommunication network that handles SMSs. And SMS is an abbreviation of, or an acronym of short message service. So the SMSC is basically the center, which is the network element that handles the SMSs. So we are creating an SMSC that will allow applications like your online portal to send a message, e.g. an OTP, to the SMSC. But then the SMSC, for it to deliver the message to the mobile station, which is the mobile phone, it has to ask for the location from the home location register, which technically is a DB that has all the profiles of the people within the network. And if they are attached to the network, then the HLR stores the actual location that you're in, or the switch that is serving you, or the switch. So definitely for the SMSC to know which switch, because in a network you can have many switches, it still needs to interrogate the HLR and get information. Send me the routing information for that short message. And the HLR will return the SRI routing information for the SM response. And inside there, it will contain the VLR or the MSC address that you're supposed to forward the message to. So once the SMSC receives the message, it sends it to the HLR, to the MSC, and the MSC will take care of the rest. It will forward the message to the radio network, which is out of scope here, and the radio network will deliver it to the mobile station, or technically what you call the mobile phone, with a SIM card that is on. And then we get an acknowledgement, which we call that the message has been delivered, or a receipt or a report, which the SMSC will eventually forward to the sending application. So we are going to create an SMSC in the next 4 to 5 weeks, give or take. And the basic idea is we are building an SMSC. It will be a real SMSC. It's not a fake one. But the HLR, we will basically build a dummy, a simulator. So it doesn't do much, but the SMSC will do as SMSCs do. So up to there, this is a recap of what we've been doing. Now, I'll just mention a few things. We have done a lot of learning. And for us to do all that learning, we have had 3 weeks of extensive study. Some of you can confirm. First week, we asked you guys to study SS7 architecture and GSM architecture. You remember us talking about STPs, or the signaling transfer points. And we also had SSP, which was the signaling switching point, and SCP, which was the signaling control point. We also went to talk about the SIGTRAN architecture. We talked about the user adaptation layers, M3UA, those adaptation layers. Basically, you can refer to them. And we also looked at the GSM architecture. So when you hear an SMSC, it doesn't shock you. When you hear a switch or an MSC, it doesn't shock you. When you hear HLR, it doesn't shock you. If it shocks you, there is hope. A lot of content has been generated. We went to week 2 and guys talked about the SIGTRAN stack in detail. So guys were able to dive deeper and study each of the layers, M3UA, and some of you guys came and presented what you had done. All the videos are on YouTube, just in case you do not, you are not part of those conversations. So we looked at the stack, the protocols that would allow us to deliver an SMSC. So we looked at M3UA, we looked at SCCP, we looked at TCAP, and then we looked at MAP. Now, the challenge that we have at hand is basically to build these things. Now, for us to build these things, I will just do a quick, I have done some notes on my notepad. So I'll just open VS Code and I will look at building an SS7 stack. Remember, we are supposed to build an SS7 stack and we are also supposed to build the SMSC. So some of you might be wondering, what is an SS7 stack? If you send requests via HTTP today, most likely you use a HTTP library, a HTTP client library, or a HTTP server library. So a stack is essentially that library that we will use to send SS7 messages, because some of you might have never interacted with an SS7 message apart from the dumps that we gave you. So I will look at the different layers that we will have in the stack. And this is for the guys who will do the stack. Not everyone will do the stack, but some of you will develop something, others will do the stack, others will do the various components of the SMSC. So I'll talk about the connection layer. So there are guys who are going to help us abstract the network connection. So during the connection layer, these guys will deal with creating SCTP associations, you know, because we know that SIGTRAN is carried, SS7 messages can be carried over IP, and that's what we call signaling transport or something, or SIGTRAN. Sometimes acronyms confuse us. We know the acronyms, but we don't know the actual meaning. So we talk about, so these guys will take care of the associations and the streams, as we heard from some of you. And the basic idea of that layer is to provide us a class which we can say send a list of an array of bytes, and it will send over the network. So these guys will be dealing with this layer. They don't have to worry about how the TLV encoding happens. So their work is to ensure that the encoding has happened and guys have put that data into an array of bytes. We pass to this layer, then they can send to the network. At the same time, if we receive data through the network, remember when you open a network connection, you can either send data or you can receive data. By the way, when we talk about these network connections, you're basically opening sockets. So these are either SCTP sockets, which are slightly different from the TCP sockets that some of you might have maybe had or played with. So the work is to receive the data and pass it over to, receive the data from the network and pass it over to the upper layer, which in this case, it will be M3UA layer. So the M3UA layer, as some of you heard, M3UA deals with, you remember in this layer, we talk about networking. It's an adaptation layer of MTP3, which is the SS7 layer that deals with networking. So here we will be talking about signaling links that are coming up. We'll be passing point codes as part of the request, the messages that are being transferred. We'll be managing those links to check whether the ASP, as someone described to us, is down. So in our code, we expect to see you having capabilities to build this. So M3UA which is basically the layer that allows us to identify network elements using point codes. So we are going to see a lot of stuff that is being, that we are going to implement. As part of the management function, we'll be able to take an ASP up or to take it down, and the heartbeat. And we also have active and inactive primitives for that you have to implement. So when I go to the source code, and for the guys who will be doing the stack, we will be seeing them writing these things for us. So that when you want to send a message, you just create a certain, you initialize something and you say, send this SMS. But behind the scenes, all these layers of the stack take care of what you need to take care of. A lot of listeners, I know some of you might have heard about listeners when you're programming, those observer patterns and all that. So you register to listen. And the key idea about listening is, remember, when data comes from the network, the stack or the layer doesn't know. So it has to listen. And the lower layer, when it receives the data, it can call the upper layer using the right listener. Even the state management, if an association goes down and the ASP connection goes down, so someone needs to be notified. So we will see a lot of those patterns, and some of you have done design patterns. These are some of the common names. Ideally, we don't have to think about them so hard, because we can look at the open source frameworks that are there for M3, for these SS7 that can serve as a guiding principle. So we will require the connection. Of course, for us to M3 UA layer to do what it's supposed to do, it requires to get the connection. So you must initialize the connection, then you initialize the M3 UA stack, and then of course initialize SCCP stack, TCAP stack, and then GSM map stack that will be able to do that. So if this concept sounds very complicated for you, don't worry. There is video, and I'll be sharing how we are going to do this to ensure that we don't leave anyone behind. Now, for those of you who heard about SCCP, we have said that map deals with the networking. M3 UA deals with networking. So technically, for those of us from IP, M3 UA basically has a way of allowing us to internetwork, or to basically reach a network element through another network element. So with M3 UA, you can reach an SMSC, can talk to another MSC, and it can go between the other intermediary network elements, can sit in between, because it supports routing. So it's equivalent of the IP protocol, or sort of, in our TCP IP layer. But it has limitation, because the identifier, the equivalent of the IP address, which you call the point codes, they are very few, because it's a 14-bit number according to ITUT, and that is not enough to cover all the network elements in the world. So because of that, the MTPUA does not serve internetworking well. So that's why SCCP, which is another layer that has two main functions from the discussions that we had. One is to do what? Is to take care of the limitations within M3UA or MTP3, which is allowing us to connect an SMSC from Uganda, MTN, directly to, it can talk to a HLR in Kenya. So the HLR in Kenya will basically, or let's say, for example, the MSC in Uganda can actually talk to an SMSC in Kenya. And it will talk to the SMSC in Kenya using global titles, which is probably the address that SCCP brings. Not only global titles, you can still use, SCCP supports routing using point codes, but the most common is global titles. And the key idea is, with those global titles, you can actually reach a network element in Spain from here in Kenya. So basically, it's like the public IP. You can reach it from anywhere internationally. So that capability comes. But also SCCP behaves the same way as TCP, the transport layer. It has capabilities for connection-oriented and connectionless communication. So in SCCP, we will see the guys who write code. They'll show us something about the connections stack, the providers, the listeners, and some of the messages that will be exchanged could be CC message, which is connection confirmation, connection requests, DT1, DT2. Remember the guy who took us through SCCP, tackled the different classes that we can take. And you have the release connection, release confirmation, or release something. I can't remember the acronym again. And then you also have data, or those guys who are talking about unit data. All those are the things that we can send. So when I say messages, it basically means one SCCP node can talk to the other SCCP node, and it's like the API and how the request looks like. So those are messages that we expect to see implemented by you guys will be doing that. But because we are dealing with SMSC and we noticed that SMSC does not use connection-oriented, it uses connectionless. So we might not need to implement all these things that I have indicated here. We might need to implement just a few. You can also pass a notice message or a message. So I hope you guys can see why we need SCCP, because it helps us do that. Now, transaction capability application part. Actually this one is, I think it's, I'm not very good with the names, but at least I know SCCP what it does. But transaction capability brings the transaction capability within SS7. Sometimes you hear the word transaction, you could be confused. Just think of DB transactions where you have to send begin, then you write an SQL statement, you insert. You can decide to roll back, or you can decide to commit. So basically, it's the same thinking that within TCAP, when you're doing a USSD session, as Samanyana demonstrated to us, you can actually do a begin, you dial a USSD code, *134#, and then you do a continue. When you cancel at the end, we do end. And in between, there could be an abort. In case the session you don't reply, the network could decide to terminate the session, or terminate the dialogue, or terminate the transaction, and that an abort can happen. And that abort will not be initiated by the user, but it will be initiated by who? By the provider, which is our stack. So when you hear those things, maybe these could help you. So the guys who will build the stack, we must see these messages, how a TCAP begin or a TC begin looks like, the different parameters encoded in those TLV, as some of you have done. Then we have a TCAP message. All these things have different parts. The transaction part. So we see the transaction ID, the originating and the destination and stuff. Dialogue part. And finally, the actual request is carried in the component part. And in the component part, I think someone did justice to us and displayed how a component can either be an invoke, a return result, or a return result last. And of course, an invoke goes away with begin. A reject can go with an end. Returned result can go with a continue, and returned result last can go with an end. So you can see the dumps and see whether those patterns do make sense. But the key idea is, if you are billing a customer as they're making a voice call for 3 hours or 10 minutes, there are many messages that are exchanged within the same transaction. So TCAP comes in handy to help us implement that. USSD also uses that. And we also saw how HLR or location update, when you switch on your phone, that happens, or when you're moving from one side to the other. So allow me to move lastly to MAP. And MAP is the main protocol of interest today, because MAP has a lot of capabilities, as we were, as Brian highlighted the other day. And we are only interested in the SMS service messages, because MAP has many other things that it can do. It can do USSD service, or it's called supplementary data. That's why it's called user supplementary service data, USSD, just in case you didn't know. At least that one I've remembered. And then we have the SMS, which is short message service messages. So we will look at, the developers will write an alert SC message. They will go and look at the primitives that Brian highlighted in the previous session, and we are going to see it being part of the code. So we will see an alert SC message as a class if you're using maybe Java or object-oriented language, and part of the attributes will be actually the parameters that Brian highlighted. So it's not complex, and we will do this together. We will also see how a map dialogue within your code, the stack, the providers, and the listeners, because as I said, if a tick-up message comes and it is meant for map, because a tick-up message can also be, tick-up can carry many other protocols, not just map. It can also carry CAP, or it can carry INAP. I think it can carry other protocols that are also part of the application layer protocols above tick-up. So the key idea is when the tick-up message or the tick-up stack receives a message, it will determine, is it a map or is it a CAP? And if it is a map, how does it determine? Remember when we were talking about, previously we talked about the subsystem numbers or the SSNs, which we compared to the pods. So it will look at the subsystem number and it will look for the map provider who is there. And when the map provider is received, we'll go to the listeners and you're going to notify this guy and say, oh, we just received an alert SC. So we are going to see how that will happen in our code. So we'll write classes that will, once we receive data from the network, we call another guy. That guy calls another guy. That guy calls another guy until the message goes all the way to the alert SC or the listener for the SMSC that will listen for all the events coming from the lower layers. And that will also allow us, and the provider that will allow us to send messages to the lower layer. So if you are a server, you need to listen. If you are a client, then you need to send. When you send, it goes downward. When you receive, it goes upward. So I hope that makes you guys appreciate what it would take for us to build a stack. But I don't know whether there is anyone with a question. Please, you can shoot on the chat and we can look at it. So I hope that has given you an overview of what the team and the presenters and the groups did over the last sort of 3 weeks and a half, where we were looking about all these acronyms that never made sense about a month ago. And I hope that you guys can make a bit of sense. If there is a thing that has not made a lot of sense, thank God. In the team, there are people who have connected those dots. And we can actually use that to ensure that everyone, as someone noted today, that eventually everyone will get the dots connected, as long as you hang around. So if you have any questions, please, you can post them on the chat. And I don't know whether we have our very good, able mentors around. I think mentors today, they realized we are doing something else. They might not be with us. But if you have any questions, you can shoot in chat. You can write it on chat, and then Marlene, you can help me note. Now, if that is the case, we have already, myself and some of the telecoms professionals have had some conversations, and we have what we believe could guide us in terms of the development, the HLD. We are going to share these notes. Definitely, this is a lot of work. I would have desired to put all these things in a document and send a very nice document. But the reality of the matter is time is not on our side, but the notes will actually help us also. So I'll talk about what we are going to create. Yes, from a development opportunity. Sorry, let me just highlight this. So the guys who have been waiting for the development, we are going to create a number of services or modules. You can call them microservices, whatever that you want to call them. And this design, it doesn't mean that it's probably the only design that can be there, but we have to start from somewhere. So we will have a message router, which will be the gateway, meaning that any third parties that need to connect to us, they'll connect to the message router. So if you have your web app that needs to talk to SMSC, or if you are a bank like KCB or NBK or NCBA, and they want to send those transactional alerts, they have to connect to the SMSC. Quote unquote, because some telcos, people have another system between the third parties and the SMSC. But for now, let's assume we have the third party up here that we talked about in the diagram that is connecting to the SMSC. So in the SMSC, it actually connects to the SMS router, which in our case is just an SMPP gateway. If you have never heard about SMPP, don't worry. Those who know and they are part of the group, they'll help us in implementing this. So there are many protocols that you may not have heard that are supporting protocols. We will also have our portal. So the SMSC will provide a web portal. So those guys who are either doing web development, will also get a chance to contribute, and we'll create a portal. And from that portal, we will manage the system. The administrators of the SMSC will manage the system. Technically, Mr. Francis Kinyoro, if he didn't move to become a developer, he would be logging into this portal to manage the connections, manage the SMPP clans, manage different things that we have. We have also designed the system in such a way that there is another component that is also part of the SMSC, and that component is called the common RX. When you hear RxTX, for those of you who watched maybe the initial video that I did sometimes back on why we need to do telco development, the intersection between software engineering and telecommunications, I mentioned the word RX. It means a receiver. When you hear RX in the telco context, it's a receiver, meaning you can call it an incoming service. So it's the service that receives requests to us. But where are these requests coming from? So they could be coming from the router, they come to the SMSC, or they could be coming from the core network and they come to the common RX. So messages could be coming from the third parties to the SMSC, or they could be coming from the network, specifically the switch, or the MSC, mobile switching center, coming to the SMSC. So these leg there, or even alert SC coming from the HLR to the SMSC. Alert SC, SC, S is the SMS center number or service center, which is essentially the SMSC. When you hear SC and SMSC, most of the time we are referring to the same thing. And alert service center is a message that we saw from Brian's presentation that allows when your phone is off and the message was delivered to the SMSC, when you did the SRI to the HLR told us this guy is not on the network. So we stored the message, waiting for you to come back to the network. When you come back to the network, the HLR will tell us, if we had registered for that, it will tell us that you have come, and it alerts us that you're here on the network. So that's why we talk about that's why we talk about the alert SC, which is also an incoming that comes to the common RX. So if you think about it, common RX will be the thing that will receive messages from other systems that are coming inside the SMSC. And that could be a third-party SMS, an OTP from your application going through the router to the common RX, or an SMS from the customer coming from the network all the way to the switch. The switch forwards to the SMSC and it goes to the common RX. Common TX is the outgoing or the transmitter. It's the outgoing service. So any communication that we take out, it will go through common TX. Why did we separate the two? Because one of the telecoms professionals said that the error handling for those services, they are very different. And of course, we separate to ensure that you can evolve or you can reach one service without affecting the other. Then we have another thing called signaling unit. So the common RX is an internal module within the SMSC or an internal service. The common TX is also part of the core SMS service. But at the end of the day, it is going to these services cannot be accessed by people who are coming from outside directly. So you either come through the router, or if you're coming from the network, you go through the signaling unit. So the signaling unit will take care of integration to the SS7 network elements. So when those guys were building the stack, the signaling unit will be purely based on that stack. It will expose a way it will create associations that are heading towards HLR, create connections that are heading toward the switch, create connections that are heading towards any of the other network element that the SMSC talks to. Now, it will be the guy who will be taking care of the messages that are SS7 in language. And it is going to get them and forward them to the common RX. If the common TX wants to send anything to the network, it passes the message to the signaling unit, and the signaling unit checks the connection that is there, uses your stack, and forwards the message to the network. And it goes all the way to the other remote service that is probably at the same level. So you have a map service running on this server that needs to talk to another map service running on the other server. But the signaling unit is the module for the service that will help us do that. Bonus service is the charging service. All of you know that SMSs are not free. So sometimes when you're doing the RX, when the MO message comes in, sometimes the RX service could talk to the charging gateway to take away your Airtime. Or sometimes when you're sending an empty message, depending on whether the sender ID or the short code is 0 rated. If it's not 0 rated, meaning that it is not a free SMS to the customer, then the common TX will send to the charging gateway, and the charging gateway will talk to the charging system, which is another system. But that is bonus because it was not part of this conversation. But if you do that, you'll definitely have a fully fledged SMSC. So those are the services we are going to have at the start that we are going to create, and we will have to look at it together. We'll also create a HLR simulator and a switch simulator, because if you're going to achieve this diagram and allow me to switch, we need this guy and this guy. This guy here, we will create it. And some of the developers here have SMPP applications. So don't worry, we can use your applications. Connect to the SMSC through the router, and the router talks to the common TX, and the common TX talks to the signaling unit. The signaling unit talks to the HLR. So that's an architecture that it's not my original idea. Guess what? I was on a call trying to have the conversations from the experts of the SMSC so that we build something that can help us to evolve and meet the market demands nicely. So that takes us, so the simulator is basically the way you could have a core banking system and you just have an endpoint that is dummy. You say withdraw this money from this account, it just says success and does nothing. That's why it's a simulator. And the MSC simulator also does nothing much. It doesn't talk to the BTS. It doesn't talk to the radio network. It basically talks to a mobile station simulator. And what's a mobile station simulator? It will just be a web app that looks like a phone. And this is where now we need you guys who are front-end developers to come and develop a thing that is able to talk to connect to the MSC. If a message is sent to the MSC to the phone, we see it here. And if you reply, then it goes to the MSC. The MSC talks to the SMSC through the what? Signaling unit, which then forwards the message to the common RX. Then the common RX determines whether this message needs to go to KCB or not. It looks at the account that shortcode belongs to and forwards to the SMS router. The SMS router forwards now to the KCB or your app or the NBK app if you're dealing with a service that requires interaction like surveys. So technically, we have a very high level document in notes that will allow us to do this. So allow me to mention some of the things, because there are some guys who are asking, can I use CSS to actually create the common RX? Sorry, I'm kidding. But there are guys who are asking, can I use JavaScript? Can I use Python? Can I use this? There are languages that would work depending on what you need. And maybe for the charging gateway, it requires backend developers. But please note, most of you who say I'm a front-end developers, you can be a good backend developer. And in the next few months, we will prove that to you, that you can actually become a very good backend developer, although you have been thinking you're a very good front-end developer, and vice versa is also true. So the charging gateway, it doesn't require S7 stack, sorry, it requires diameter stack. Another protocol you have not heard, that's why it's a bonus module. So you don't need to worry about the diameter stack because the billing system talks diameter. Signaling unit requires the SS7 stack. I have written Java here, but I will say etc because one thing is we must build at least one stack in one language. And for us to control, Meliora and team has agreed to support the development of a Java SS7 stack. So in the event you want to do Kotlin or you want to do Python, we might need to see what will be done. But at least for the initial release and for us to guarantee delivery, we must develop a stack in one language that probably from our side, we can guarantee that we will finish. Doesn't mean that other stacks cannot be created. So we'll do design sessions, and if you want to port the same library into another language, you can easily do it, but we'll have to do maybe the Java as the example, and then you can port yours to the other language. So Common TX just requires backend developer. Java, C, I think even Python could deal with that. Node.js guys. Common RX, because these are internal services. Same stuff as Common TX. Portal, it will need both backend and frontend developers. Just one module, but you could break it into two small. You could have an API at the backend, the data model, and the DB at the backend. And maybe we can spearhead Spring Boot Angular from Meliora. Some guys could do Spring Boot React. We're using these languages because some of the telcos and the corporates that we work with, we have seen them adopt such stuff. Like I was at Safaricom Summit, and I think they mentioned that their APIs are done on Spring Boot. So if you're able to learn how to create one on Spring Boot, who knows? You might know how to do an SMSC, and you might also know how to support the development of services within Safaricom, or even KCB, I know they use that. And this could allow you to, and I know Telcom also uses that. Because I've interacted with some people, I know someone would have judged me that I'm not mentioning them. Yes, Telcom also uses Spring Boot. It depends, and the teams might decide on what to do. But in the event you don't decide and you don't deliver, we can front whatever that we are comfortable with, so that we guarantee a delivery. So SMS router, this requires people who understand SMPP. Some guys here understand SMPP. Yes, let me call it SMPP stack, or some people would call it a library. SMPP and diameter are cheaper in terms of complexity and understanding and implementation than SS7. So if you guys crack this, you can build your own SMPP stack, or you can look at an open source stack that allows you to do that. I know some of you might be asking, so we are doing SS7 stack and we are creating our own. If you Google, you'll find some open source stack. Someone asked, why are we creating this? Because we want you guys to know. You take a lot of things for granted if you adopt a high-level stuff created by someone else. And since you guys spend so much time reading the RFCs and the technical specification documents and those standard documents, it only makes sense for you guys to attempt and create these things. Because one of the things we know, if you do not create, you always play a catch-up game. So if we really, really desire to help the world and contribute to what is happening in the world, we must be willing to create. Why do we create? Well, we have so many things that we can do. That one is a hoax. Majority of you are not busy. So we are going to create. And I believe all of you have voted yes. So we are good in terms of the development opportunities and what presents to all the guys who are here. This is not a thing that you can pull alone. So that will take me back to something that I wanted to say here. There is no one who can create this thing, and we desire, and this is by design, no one should be able to create this thing alone. So, but before I go there, I think I mentioned something here that the SS7 stack will be open source. The SMSC, we are not so sure. So for now, we might not make it open source, but the designs will be open just in case you want to go implement it yourself. But the source code, for security reasons, we will have to consider. Some of you might not know that a lot of vulnerabilities and abuse that happens on our systems is because maybe the source code is open and hackers can check the vulnerabilities here and there. So we promise to make the library stable and very simple with very secure interfaces. But the SMSC, we might need to put it aside. And it doesn't mean that you guys won't know the design, but anyone cannot just wake up and look at it. And you guys can look at it, you can know the weaknesses, and I believe you're good people. You have believed in the story of Natujenge taifa letu, not Natuhack server zetu. So that's the basic idea behind that. So we require a dedicated team, at least a dedicated team for the stack. And if possible, a dedicated team to do the designs. I know some of you might have had scenarios where someone told me, create this thing for you, and you just code the whole night. I have said that software engineering is 20% right in code in the past, and I could be wrong. It could be lower or slightly higher, but trust you me, it's not half of what we do. Writing code is not half of what we do in terms of the end-to-end software engineering process. So it is a lot of talking and few moments of writing code. And why do we talk? Because we have to work as a team. So we need to ensure that our contracts and our engagements, the APIs, the payloads, the models, the process flows are well understood by the whole team. So we will also need to have that. And I think the group leaders might have approached some of you to find out whether you're fully available. I know that in Kimathi team, you don't have an option. You have 3 weeks at home. And most of you are not voting against our wishes. So you have all the time to code. So we will need you guys to come forward, volunteer, and we do this thing every single day. And my hope is that the guys who are here, professionals who are listening or who will watch this video, that by the end of this, we will have a summit, and that summit, we're going to demonstrate what we've done. One thing I would like to mention is we've had conversations with some telcos, and they're willing to support you guys, not just to have an SMSC that you look at it. They can actually put it on their network, and you can send an SMS with your phone, and the other guy receives it, and this is handled by your technology. And that will be a very, very great moment. So the SMS components do not require the SS7 can be developed in parallel with the stack. So that's the other thing. So the stack team, together with some of the modules. So the guys who will be working on let me give an example. The guys will be working on the design for the portal can actually do the design as the team that is doing the stack is ready. But we must all agree how these interfaces are supposed to work for them to continue with the development. So mentors are still needed. So if you're a professional, we still need you guys to come and deal with our stupidity. Commitment is there. And we have seen it. We have no doubt that the guys are there. There are people who are very excited. As I speak today, I think I was joking with someone. Today, I happen to be a guest of the Green Army. I'm at Safaricom HQ2. And I told some of the guys that we are doing this, and people are willing to support. Of course, until we send the SMS, we will know whether they mean it, but I have no doubt. So mentors will do process modeling, data modeling, UX models, and we'll also keep some good documentation so that the guys who started these libraries, other people can come and improve or make them better. That's the spirit of open source and collaboration. So that means we will need you guys to be dedicated for the next few weeks for us to deliver this. Some of you have already expressed interest to get into a daily stand-up every day. We will try our best within our busy schedules to come and support you. So that's what I would like to say. And that takes us to the end of how we are supposed to implement. Maybe the only thing I can ask is if there is anyone with a question, they can ask. And before I conclude with the boundaries of the components and what each component will do, and then we can end them.
There are two questions in the chat.
Yes.
And the first
Jackson.
one is from Jackson. Yeah. He's asking if there's any code you can take us through, any code that is a similarity of what we are yet to create, if I'm getting the context right.
Yes.
And then Cyrus is asking if we're building an API of our own.
Yes, Cyrus, I can start with Cyrus's question. Yes, Cyrus, King Cyrus from Persia. Yes, we are building our own APIs. We're actually building everything there. So let me give an example. API is one of those words that has a lot of meaning. And for those of you who have been with us during Natujenge season 1, which is long ago, we have video recording, but we've not been given them to you. An API has a lot of meaning. Most of us think of API and we think of HTTP API. Yes, we are going to build HTTP APIs. Where will they be? One will be on the message router speaks SMPP. The portal here will do HTTP APIs. And for those guys who do Spring Boot REST controllers, this will be an easy task for you. So we are going to create APIs. When you send a request, it goes all the way to the service and talks to the DB, either to retrieve or save data. Yes, that's correct. But I'll also mention that APIs are not just HTTP APIs. We'll also create an SMPP API. Now, the biggest question would be, how will common RX talk to common TX? And some of you might be asking, why do they need to talk? Let me give you an example. Marlin sends a message to Kamochu. That message is MO because it is initiated by Marlin. Goes all the way from the network, goes all the way to the MSC, the switch, and the switch forwards the message to the SMSC through the signaling unit, and the signaling unit forwards the message to the common RX. Now, once the common RX receives it, it sees that this message is being sent not to a shortcode, but to another number. And what the common RX does is that it forwards the message to the common TX to basically transmit the message to the B party. So how will common RX talk to the common TX? We might agree, but remember, since this is a very high TPS system, you could use queues or you could use APIs. So yes, there are opportunities for queues and there are opportunities for APIs. Of course, when you're using queues, when you want to deal with an SMSC that can handle 20,000 TPS, you cannot use a DB to insert a record, then the other guy reads the message from a DB table. That will not work. So we either use an API, very fast, maybe binary-based APIs, or we use a HTTP API, but we ensure that we take care of the connections. We reuse the connections. So there are many things that you're going to do, and as we're doing the design, we'll answer those questions. Yay, Kibet, I've seen your question, but before I go to your question, I'll finish on the last definition of an API. Those guys who in Java learned about an interface, that is a programming interface also. So when you're dealing with an SS7 stack or your HTTP client, someone might say you're dealing with a HTTP API implementation on that language, which is also true. So APIs will be seen, but the APIs that you might be thinking about are those you send through Postman. Yes, they'll be there for different things. Don't worry, we'll guide you there. Mr. Jackson Mwangi, I'm trying to go through the open source project shared. Hello, I'm a beginner in this, and I'm trying to go through the open source project shared. And so I was asking if you could take us through the source code kindly. Mwangi, if you're interested, the weekly sessions, the guys who are building the stack, they'll have to definitely compare notes with the documents and the presentations they did with the open source code and the dump together. So yes, we'll get enough time to look at those open source code, and we are going to borrow a lot of things to build our own stack. So Mwangi, don't worry, Jackson. If you have not been part of the conversations, don't look at the code before you look at the videos. So you have a very long task ahead of you if you are starting, this is your first meeting. So I can also see Kibet asking, do you see us using the modern technologies like Docker, Kubernetes, OCP? Yes, Kwana Kibet. Those decisions have not been made. If you guys decide, that's what you're going to use. But you're not going to use the traditional deployment. So we are going to do CI/CD. So if some of you are DevSecOps people and you're available, we will come and ask you to help us in helping us deploy in this way. Clustering with SMSC, Mark Gugi. State management and mirroring should be fun. Oh yes, Mark, we should be able to do that. In the initial release, and now that we mentioned it, we will talk about scalability of these modules, and we'll get the guys and the professionals to come together and help us. But for us to do the first release, we can do it without clustering, so that if you're deploying on Kubernetes, those who know Kubernetes, we do one pod per service, and then later we can have another session where we look at how we can scale linearly, and that will be fun. I believe so. Kibet, asante. Yes. So we are excited, and we are hoping that the excitement will continue. So I don't know whether there is someone else. I'm feeling really, really nice that you guys have asked questions today. I think you are all waiting for the code. Marlin, maybe the next time we should just write code. We start with the confusion until we figure it out.
Yeah.
Yeah. So someone else. Yeah. So Evans, I'm hoping that, so we are looking for guys who could be available either on a daily basis, especially in the execution. For those who can, we will agree. And Marlin will help us, will coordinate us to ensure that we get you guys coming, but there'll be a daily meeting. This one, we can't do it the way you are doing research. Yes. So someone was asking about, is there anything that was asked that I'm leaving out? Or there is Cyrus, King Cyrus. I feel like you have asked another question before. Will a community channel, e.g. Discord, be made in order for different people or devs who know maybe front-end or back-end can come together and work on these projects? I'm not so sure, Cyrus, how to answer that question. But one thing I know, I read a paper sometimes back in 2014, a white paper, sort of a research paper by professors. And I was looking at the question of collaboration. 7 years or 8 years fast forward, the collaboration opportunity is here with us. The lesson and the key thing that I've never forgotten, and every time we are working, even in Meliora, Kinamalin, they know this. There are no great systems that are created by one person. So you need a team. But there is one thing that paper was talking about when it comes to the success of a project. It says that in life we have connections as human beings. Thomas Njoroge from Telcom talks to me once in a while. Thomas has another colleague called Joseph. So we are three of us. Thomas and I keep talking. I do front end, Thomas does back end. And Joseph does back end also. But Joseph doesn't talk to me a lot. So our social connection over the weekend, we don't talk. But Thomas, we go hiking together. So the basic idea is this. In the design, when we look at these components, because this is now an architecture, for those of you who didn't know what an architecture is, this is a high level design for our solution. The skill sets that are needed here are very different, or they are varied. If you want to have success, we need to match the social patterns, which are the social connections between people, with the technical patterns. If common Rx talks to common TX, then if common Rx is being worked on by Thomas in this same project, common TX should probably be worked on by Samuel and not Joseph, because Thomas has no connection with Joseph and Kamochu has no connection with Joseph. If we do so, then we have a very high cohesive team that will give us success. Why am I worried about the community? I would tell you guys, the people who can deliver are the people who have been working together. So yes, we can open it up, but we need to be careful because you might find guys who are doing stuff. I think for now we could do with these and we see whether we can. I mean, Marlin, you did a survey. You can talk to Cyrus and see whether Discord can help us. But allowing other people to come. One thing I can tell you, this is a very complex subject. If you have not been with us for the last 3 weeks, you may not come in and start commuting code. Maybe on the portal, we can show you 1 or 2, 3 things, or maybe on the API on SNPP, if you come with some background. But I would say my bet is you guys who have been part of this can be the ones who can deliver these things in the shortest time possible. Yeah. So Cyrus, we will try and see. We don't want to create a channel or a tool where we are not making maximum use of it. So we will need you guys to come and give Marlin ideas on whether we can move. Will it be Java based only, or there is an alternative language? My recommendation is this: for us to have something that works out, the guys who can come together, we do the designs and they can implement the Golang version of it, or they can implement the Python version of it. But at least we know the Java version, we will, because we have to demonstrate. So maybe I might ask you, Michael, and maybe you don't have to answer, but sometimes you might go to a language and you find that it doesn't have primitives for you to create an SCTP connection. Most languages you might find, or most things can support TCP, UDP, but they don't have TCP. I know Java has SCTP, so I am so sure that with Java we can achieve everything. I also know C has everything, but unless I am like Brian, who is bold enough to do everything in C, I am sure that Java we will deliver, because I will ensure that we actually deliver, and I'll help the team so that we move forward. Trust developers, rise. So let's, Marlin, I think what we could do is, let's start thinking about what we can do. We can do a quick call tomorrow at some point, and Marlin, maybe you can talk to the people that had volunteered. Once we do a quick call, we can agree on the schedule for making calls. Some guys might be, I'm working in another organization. Can we be doing this call from 7 to 8? If that's your option, whatever you vote, we can do those calls, and we can probably find a way of recording the sessions so that guys can move with us on a daily basis as we move towards the target. What we've done was amazing. Where we are going, we need a lot of input. Walter Onyango said, you guys are tougher. You need to live by that statement and show us that you're actually tough. If you do this, I might not paint a good picture of the opportunities that lie ahead of us, but for those of you who are people of faith, you can believe me that there is a lot of hope. You can walk around the street asking whether there is anyone who has ever created the thing we are talking about, and you can see. Ayusi, I think you are drawing on my screen. I don't know how I can rub. If in case you know how to rub, you can rub for us. So I don't know whether there is any question, but basically we have shared what each and everything is supposed to do, the functions of the DB queues, and some of the implementation notes that the experienced developers have given, or not the developers really, but people who have been working on the SMSC live. So they're telling us what we need to do, and we need to enrich this as we continue. So you can see what the Common Direct service will do. So we will share these notes with Marlin once we put them in a nice way. We'll also see what the signaling unit will do. It will basically manage the connections, the SS7 connections. So if our SMSC is supposed to connect to a VLR in a different country, so the signaling unit will handle those connections to those other countries, to a HLR, that is, not a VLR. Yeah. So we need, or even a switch to in a different country, like you're roaming in Spain. So all those things will be there. So that's it. In the event you have any comments on the design, because remember, we are not perfect. This could be a good design, but there could be a better design. Please feel free to share your comments with the team. And let's begin the code. I know you guys have been waiting for this moment for so long. Marlin, over to you. unless someone has any other question for me. I will stop sharing now.